And what do you mean by coding? Whatever algorithm as well as flowchart we have written, that we are going to converting into programming language. By using algorithm as well as flowchart, we will represent what is the action now we want to perform. By using some programming language, I am writing the program to perform addition of two numbers. That is nothing but coding. By taking sample data and checking whether it is working as our requirement or not is called as testing. Welcome back to one and all. Myself, Vasanta, lecturer in computer science, Vidhyaashram, Pre-University College, Temple of Excellence, Mysore. Today, we are going to start with the first session of problem solving methodology. This is the easiest chapter, and with that, this chapter carry highest weightage. Whereas the total weightage in the annual exam from this chapter is 11 marks. From this chapter, you will get 11 marks in the annual exam. In part A, one question for 1 marks. Then in part B, one question for 2 marks. Then in part C, one question for 3 marks. And with that, in part D, one question that is for 5 marks. Totally, from this chapter, you will get 11 marks in the annual exam. Whereas on today's session, you will come to know the regarding what do you mean by problem solving methodology, that is introduction regarding the problem solving methodology. Under that, the stages of problem solving process, which are the stages, that is problem definition, problem analysis, design of a solution by using algorithm as well as flowchart. Then what do you mean by coding? Program testing and debugging, documentation and maintenance. The stages of problem solving methodology. Then what do you mean by, first of all, problem solving methodology? Here, the problem solving process starts with the problem specification and ends with a complete program. What exactly we want to do, on which method we are solving the problem. First thing, which is a method that we are solving here. Problem solving methodology or a process starts with the program specifications, which are the requirement specification, and ends with a complete program. Finally, we are going to get the complete program regarding this. When we come on problem solving process, it involves several stages like problem definition. It means that in the first step, what is the problem that we have to identify here. Then problem analysis. Analyze the problem, requirement, everything you have to analyze here. Then design of solution by using algorithm as well as flowchart. Then algorithm is nothing but a step-by-step procedure to solve the given problem, whereas flowchart is a pictorial representation, or I can say it is a graphical representation of an algorithm. Then next one, coding stages. Then what do you mean by coding? Whatever algorithm as well as flowchart we have written, that we are going to converting into programming language, where it may be any programming language, whereas C, C++, any programming language. By using some syntax and rules, when we are writing the program, then it can be called as coding. Then program testing and debugging, whereas testing is nothing but by taking sample data and checking whether it is working as our requirement or not is called as testing. Whereas debugging is nothing but correcting the mistake. Whatever mistake we have done, the correction of that mistake can be called as debugging. Whereas testing is nothing but by taking sample data and check whether it is working as our requirement or not is called as testing. Whereas debugging, after identification of the mistake, correcting of that mistake can be called as debugging. And the last stage is documentation and maintenance. Whatever stages, whichever problems we want to solve, that we have to maintain. Regarding that, we have to maintain the documentation. One by one, we'll explain. Problem definition. What do you mean by this problem definition? Already I told you, when they come on the stages of problem, the first stage itself, problem definition. That is identification of the problem. First, you have to identify what exactly we want to do. That is nothing but problem definition. Here, we define the problem. To solve any complex problem, first we have to understand the problem by specifying the problem requirement for desired result. What do you mean by that? In this, what is the problem? That first we have to identify. For example, if I want to prepare a sambar, consider that is the agenda of the program. Then on that time, first I have to identify which type of sambar today I have to prepare. Whether dal sambar or which type of sambar today I have to prepare. Regarding that, identification of the problem is very important. That is the first stages. That is problem definition. Then the next stage, problem analysis. While analyzing the problem, we have to identify what are the inputs, from that what will be the output we are getting, then whatever additional requirement is required for this process, everything we have to analyze here. For example, if I want to prepare a sambar, especially dal sambar I want to prepare. Identification is that problem definition. Then analysis, I have to check whether the dal is already present in the home or not, where I have to purchase from outside or not, or whichever the vegetables I can use there. Already the vegetable is present in the home or I have to purchase from outside. The requirement here we have to analyze here. Whether the requirement, whatever requirement we want to perform here, is it sufficient or not? That also we have to identify. For example, I want to prepare a sambar for 10 members. Then in the home I have to check, cross-verify, whatever dal presently I am having, is it sufficient to prepare the sambar for 10 members? Like that, we have to analyze here. That means whatever input data is required for the processing, then from that what is the output we are getting, and any additional requirement for that process. Where I want to prepare a sambar for 10 members, I have to cross-verify whether dal is there, all the vegetables are there. Where I am having the container to prepare a sambar for 10 members, everything we have to analyze here. Analysis, that is problem analysis. And the next one, design of solution. What do you mean by this design? Here, we represent the solution to the problem using the tools such as algorithm and flowchart. By using algorithm as well as flowchart, we will represent what is the action now we want to perform. Whereas, for example, if I want to prepare a sambar, for the first step, I have to switch on the stove. Above that, I have to keep the bowl, then water, dal, then vegetables. Like that, I have to write the procedure first. Then afterwards, whatever procedure we have written, afterwards, we have to convert that into flowchart. That is in pictorial format we have to represent. For example, if I want to perform addition of two numbers, then what is the first step? Step 1, start. Step 2, input the variables, whichever variables we require, that we have to input. Input A and B. Then in third step, step 3, calculation, that is C equals A plus B. Step 4, output the result. The result is present at C. Then output C. Step 5, stop. From this, what you can identify here, algorithm is a step-by-step procedure where to solve a given problem. Whereas here in addition of two numbers, first step I started, second step I will input the values A and B. In third step I calculated C equals A plus B. Then fourth step I will display the result. Finally, I will stop here. It means that algorithm is a step-by-step finite sequence of instructions here. This is the step you have to perform. Finite sequence of instructions here to solve a well-defined problem. It is a textual representation of a solution to a problem. In the format of text, here we are writing. That is about algorithm. But when they come on flowchart, already I told you it is a pictorial representation. In the format of graphic format, we are going to representing. Here itself, I want to perform addition of two numbers. Step 1, start. Then input the variables. Input A and B. Then step 3, calculation, that is C equals A plus B. Then step 4, output. Here output I have to write in parallelogram symbol. Then here output is, see here, finally next last step, stop. It means that in the graphical format, in the pictorial format, when they represent this algorithm in a graphical format, then it can be called as flowchart. Whereas it is a diagrammatic representation of a solution to a problem. Whatever problem we have, diagrammatical format will represent. It uses geometrical shapes to represent a sequence of instructions. Some particular shapes here we are using. For example, here oval shape, then rectangle shape, parallelogram shape, rhombus shape. Like that, we are using several shapes here to represent the flowchart. Next is coding or programming. Whereas here, I have written the algorithm, whereas in coding section, that we will write by using some particular syntax in some particular programming language. That is nothing but coding. It is a process of translating the algorithm or a flowchart into the syntax of given programming language. For example, by using C or C++ program, I want to do the same calculation. First step, I want to declare the header file as include iostream.h. This is the supporting header file for C in as well as C out. Then void main in the main program. Void main. Here in the declaration stage, whichever variable I want, I can declare here. For example, int A, B, C. Then in the output screen, it has to be displayed C out. Enter A and B. Enter A and B values. Enter A and B values. Then input that value C in extraction operator A, extraction operator B. Then calculate that C equals A plus B. Then display the result C out. Insertion operator sum equals. Display the value C. Then close the main program. From this, what you come to know? Here, by using some programming language, I am writing the program to perform addition of two numbers. That is nothing but coding. Converting this algorithm as well as flowchart into a programming language is called as coding here. The next one is testing. What do you mean by testing? Already I told you in problem definition, identification, problem analysis, analyzing the problem, whatever requirement is there for that process. Is it sufficient or not? That is analysis. Then design rule, that is writing that in the format of algorithm and flowchart. Whereas coding stage represents converting this algorithm as well as flowchart into programming format. Then what do you mean by this testing? Testing is nothing but taking a sample data and check whether it is working as our requirement or not. For example, mother prepared the sambar. On that time, she used to take the sambar little bit, only one spoon of sambar she used to take, and she will going to test it that. Whether is it sufficient or is it correct, like that she will check. While testing, she is not going to take the entire sambar, she will take only spoon of sambar, then she will check that. It means that testing is nothing but taking a sample data and working whether it is working as our requirement or not. That is nothing but testing. After identification of that mistake, correcting of that mistake can be called as debugging. Whereas testing means running the program or executing all its instructions, functions and checking logic by entering simple data to check the output, or by taking only sample data, simple data. We will check whether it is working as our requirement or not. That is nothing but testing. Then, what do you mean by debugging? Already I told you. Whereas identification of the mistake can be called as testing, then correcting that mistake can be called as debugging. Whereas debugging is the process of finding and correcting program code mistake are called errors. Here, whatever errors we have, that can be corrected here by using debugging process. Debugging is nothing but correcting the mistake. Whereas testing is nothing but by checking or by giving sample data, we will check whether it is working as our requirement or not. The next stage is documentation. Why we need this documentation? It's a process of writing all the instructions in some systematic manner. Okay, first, for example, if I want to prepare a sambar, for that, what is the first step? Like that, everything I will make a documentation. First, I used to switch on the stove. Above that, I used to keep the bowl, then water, dal. Like that, whatever steps I have done regarding that, the documentation here we have to perform. That is, it is a reference material which explains the use and maintenance of the program. How we are using, how we are maintaining, or the application for which it has been written, for which purpose we are doing this program. All those things, the explanation regarding that program can be called as here documentation. There are two types of documentation. One is internal documentation and one more is external documentation. Documentation is nothing but writing the instructions, what exactly we are done, for which purpose we are writing this program, what is the main use of that, regarding that, the explanation regarding that can be called as documentation. Two stages, two types we can able to perform. One is internal documentation and one more is external documentation. Then, what do you mean by this internal documentation? It's also known as technical documentation. This also can also be called as technical documentation. It means for programmer who may update the program code at later stage. For later stage, when you want to update, then we need this internal documentation. Whereas external documentation, the program or application is supported with additional textual information about the application. It is useful for user administration or a developer. Here this mainly used for administration purpose as well as for developer purpose. We need this external documentation. Next, when we come on maintenance, this is the last stage. Why we have to maintain the program, for which purpose? For example, after completing the exams, you are not going to throw the notes, is it no? You are going to keep your notes for future purpose. Is it no? That is nothing but maintenance. The data or whatever program you have done, that has to be stored for future purpose. While storing the program, it may be in pen drive or it may be in hard disk. Any storage, secondary storage devices we are using to store the data for future purpose. Whereas program maintenance means periodic review of the program and modification based on user requirement. How the user want, on that way we can able to modify if you have maintained that for future purpose. And when we come on algorithm, already I told you it is a step-by-step procedure. Step-by-step procedure to solve a given problem. For example, if I want to perform multiplication of two numbers, what is the first step? In the first step, I used to start multiplication of two numbers, that is C equals, I want to perform A into B. Then how to write the algorithm? First step we have started. In step 2, we have to input. If I am going to give the value A and B, then I can able to calculate C. Then here, what I have to do? I have to input the variables A and B I have to input. Then next step, in step 3, I am doing the calculation, that is C equals A into B, here I will perform. Then after that, step 4, we will display the output. Where exactly the output is present? At C. Then output the values. Output C. Then finally in step 5, stop. It means that algorithm is a step-by-step procedure. Here first step this I have done, second step like this I have done, fourth step like that. I am dividing the problem. Here in step-by-step I am explaining the problem. That is nothing but algorithm. Next, when we come on the characteristics of algorithm, some particular characteristics here you have to follow. The first one is input, definite, effective, terminate and output. These are the major characteristics of algorithm. First one, input. What do you mean by this input? The algorithm must accept one or more data to be processed here. If I want, an algorithm must accept one or more data to process. Then definite, each and every instruction must be clearly specified that what should be done here. If you observe here, each and every step will tell you what exactly you want to perform. That is, now we are started, we are inputting, we are calculating, we are displaying, now we are stopping. That means each and every step has some specific meaning here. Then effective format you have to represent each operation step can at least in principle is carried out by person using a paper and pencil in minimum number of times, as much as possible. Minimum number of times we have to write the instructions, have to reduce the instructions here. Effective format, I have to write the program. Then terminate, after processing all the transaction, must and should, it has to stop. See, if you observe here, at the end, compulsory here I stopped. That is nothing but terminate. After some minimum number of steps, algorithm must come to an end. And the last one is output. Algorithm must produce one or more output called here, especially the result can be called as output here. Compulsory, finally, if you observe here, finally must and should, we have to get some result. These are the major characteristics of algorithm. Then next class we will explain the remaining concept, like what do you mean by if statement, if else statement, then how to write a program, or how to write algorithm, how to write a flow chart for specific functions, operations. Regarding that, next class you will come to know. Thank you for all of you.